Hello, geometry. Welcome to lesson 7.5 on proportions in triangles. This is the final lesson of topic 7. And again, we're going to take our ideas of similarity and the idea that sides are proportional and extend them into some specific theorems involving proportions. Okay, so it should be a fun algebra-y lesson. Okay, all right. So it says in triangle JLN, if LN equals 9.6, what are LM and MN? Are the sides divided proportionally? Explain. Okay, so if we take a look at this, the first thing I want to do is I want to prove to you that these two triangles are similar. Okay, so the two triangles I'm talking about are the top triangle LKM and the big triangle LJN, right? The small and the big. Okay, so this small one and then this big one. And the way I'm going to do that is by using the idea of these two parallel lines, right? If parallel lines are present, then you have corresponding angles. Now, first off, though, I don't need the parallel lines because we have angle L, right? Angle L is in both the small triangle and the large triangle. So angle L is congruent to itself. That is by the reflexive property. And that's one angle pair, right? And now let's go ahead and use angle LKM and angle LJN, right? Angle LKM will be congruent to angle LJN because they are corresponding angles, and you have the corresponding angles theorem. And again, it's because these two lines are parallel. And now we know that triangle L, all right, I used KLM, I guess alphabetic order, KLM is similar to triangle JLN, and that is by angle-angle similarity, right? I know that. So now, based off of what I'm given, I should be able to create some proportions allowing me to use the numbers I'm given, right? So if I take a look, I want to find what LM is. So LM is here, so let's call this X, right? So let's create a proportion, and they gave us that ln is 9.6, right? So ln is 9.6. So over here, they gave me 3 and 5. So I know that this side is 3. I also know that this long side is 8 by adding them. So if I use the small triangle and the big triangle, I want to find lm. So lm over, well, lm are the second and third, so that'd be over ln, which I know. And then let's also use lk or kl. Let's use kl, if you will, which is the first and second over jl. So I think I know all of these except for LM, right? LM is X. LN is 9.6. KL is 3. And JL is 8, right? I'm going to cross multiply. So 8x equals, and 9.6 times 3 is 28.8. Divide by 8. I'm not going to show you that again because you don't need to see that. And when you divide, I'm just ingrained, but you don't need to. And when we divide by 8, you get 3.6. So what that's saying is that LM is equal to 3.6. And now that you know that this is 3.6, you can just use subtraction to find MN, right? So to find MN, take 9.6 and subtract 3.6. So MN is just plain old 6. And now what we're going to do is we're going to say, are the sides divided proportionally? So let's compare these smaller sides, right? Let's compare KL to JK, right? So we're not using the triangles anymore. We're just comparing the sides going down the triangles. So I'm going to compare, I'll put LK over KJ, right? That's going to be 3 over 5. And when you do 3 divided by 5, you get 0.6. Okay, so that's that ratio. And now let's do LM over MN. That would be 3.6 over 6. And when you divide those, you also get 0.6. So what this is telling you is that LK over KJ, right? These two sides, right? So side 1, or segment 1, segment 2 is equal to, this is LK, right? LK, sorry. LK over KJ is equal to LM over MN, side 3 and segment 4, right? This is a big idea because instead of needing to know the entire length of the triangle, we can just use the parts. And all we knew was that these two lines, these two segments were parallel, right? This is going to introduce us into an idea appropriately called the side splitter theorem, right? What a cool name, side splitter. It's like a, I don't know, side splitter. So here we go. So it says if a line is parallel to one side of the triangle and intersects the other two sides, then it divides those sides proportionally. So we need parallel lines, which we have here, MN and AC, and then a proportion, right? In this proportion, it's AM over MB. 1, 2 going up the side is equal to CN over NB going up the side, 3, 4. Okay. Now, there is a special case to what's called the side splitter theorem, which also involves your M and N being midpoints of your side. And it's called the triangle midsegment theorem. So here it is. So it says if a segment joins the midpoints of two sides, so again, now we have this idea of joining the midpoints of two sides, then it's going to be parallel to the third side. So give me a second, because there's two important ideas. This segment is going to be parallel to the third side. So that's idea number one. And it's half as long as the third side, idea number two. So in this picture here, you see that G and H are marked as midpoints because you see the congruence markings, right? So we know that G and H are midpoints. So because of that, we know that GH is parallel to DF. And we know that GH is half of DF. So if DF were to be 2x, GH would be just x, right? Very important here, okay? And again, this is just a special case of a side splitter. I'm going to pause for a second, get my Savas up so we can use this manipulation tool. All right, so here we go. Let me click on this manipulative tool. And let's talk about the triangle midsegment theorem. Right? So we can't really talk about the parallelness, right? They look parallel, but we can see that, okay, 5 and 5, 4 and 4, so G and H are midpoints. And if we move any other point, right, notice what happens to, the length of these third sides. 6.18, 12.36. This is half, right? Let's see if I can get a nice number. So 12. Sorry, almost. Let's do maybe 8. Can I get 8? So that should be a 4, right? 8. There you go. Oh, again, I'm trying to do it with my pen. All right, anyway, you get the idea, right? That is going to be half that third side, right? But again, has to involve midpoints. Okay, cool beans. All right, so let's take a look at maybe some problems. Yeah, I got 3, okay, that are all involving this. Okay. All right, so let's go. All right, so question, this one, it says, what is the value of x? Okay. Whoa. Okay, so this is a very complicated question, right? So you look here. You, in this picture, know that ST and PR are parallel, right? So I'm going to ignore Y for a second because I don't know anything about Y. I'm going to ignore it, right? So I want to find what X is. So I have to use PS and then SQ, this entire side up here, not where do I? So 4 plus 12 is 16. Same thing over here. I want to use RT and then TQ, right? 9 plus 3 is 12. Okay? So I'm going to do x plus 2. I'm going to put my binomial in parentheses. X plus 2 over, and I'm just going to go up this side, over 16 equals, and I'll go back over here, equals x over, and again I'll go up this side, x over 12. Okay, so we're going to cross multiply. Now, if you know to distribute the 12, you can, or you could just write it as 12 times x plus 2, whatever you want to do, equals 16x. And now distribute 12x plus 24 equals 16x. I'm going to subtract 12x on both sides to get my x's combined. 24 equals 4x, and I'll divide by 4. And I got an x value of 6. And there we go. And you can always plug it back in to make sure it does create the proportion you wanted, okay, if you want to check. Perfect. All right, so next we have one more idea, kind of an extension, or they call corollary to the side splitter theorem, and this is just about multiple parallel lines. If you have 3 pairs of parallel lines that intersect 2 transversals, then the segments intercepted on the transversals are proportional. So how? We don't have like this closed top, but now you can look and see, okay, I still created 4 segments, right? So AB over BC. So I created segment 1, segment 2. So now I'm going down this. So then come back over here, segment 3, segment 4 going down, DE over EF, right? So again, the idea is about the segments still being proportional, and you really don't need a triangle. So no triangle, but it's not a big deal. Okay, so last problem on this video. Let's take a look here. Okay, so it says a reflecting pool is separated by sidewalks parallel to Lincoln Street, right? And Jefferson Street, which are parallel to each other. The city wants to add additional tiling around the pool. How much tiling does X feet represent? So here's X feet, so we're looking for this amount of tile. They said that the walkways are parallel to each other and Jefferson and Lincoln Street. So we have this parallel lines idea from before. So we can go down this side, we can go down this side, and just use the little ones. We don't need this piece right here. Okay, so I'm going to do X over 60 equals 24 over 72, right? I'm going to cross multiply 72x equals 24 times 60 is 1440, and then divide by 72, and x is 20. So I need 20 feet for tiling. All right, great. Here's the end of video 1. Video 2 is coming up.